Born in 1813, Henry Bessemer was one of the greatest inventors England has known, whose genius covered an amazingly wide field of endeavor. Machines for the production of type, glass, sugar, paint were only a few of the 100-odd patents which filled volumes with the output of his fertile mind. Practical invention was Bessemer's answer to any problem. He was a bad sailor, so he produced the remedy, a passenger saloon that remained upright however much the ship rode. It was not a great success, but at least it was evidence of his imaginative brain. He was 41 when the Crimean War began, and he gave his mind to artillery problems. He produced a shot that could be revolved by the exhaust gases through the smooth-bore cannon of the day. It was grooved, and Bessemer showed its effect with a model. The principle was sound, but the iron guns of those days could not stand the increased pressure. Bessemer's reaction was to find a stronger metal, which he cast into gun barrel molds. He was turning his genius to what was to become his life's work, steel. Developing the old puddling furnace, he found that a current of air blown over the surface of the metal not only raised its temperature, but helped to remove the carbon and other impurities that made the iron brittle. Soon he was blowing air through the molten metal and found that this by itself produced enough extra heat to complete the refining process. Then, by putting back a controlled amount of carbon, he could produce what he'd been working for, a metal that was hard and strong without being brittle. Still, he was not satisfied and continued with his experiments. By trial and error, by adapting his old ideas and devising new ones, he eventually developed the converter we know today. He could make steel, acid Bessemer steel, stronger and cheaper, more quickly and in greater quantity than it had ever been made. And he gave Britain such a lead that within a decade, she was producing more steel than the whole of the rest of the world. His announcement of his original principle 100 years ago is seen now as the beginning of the steel age. Bessemer had his failures. He also had help from men like Mushet and Joransen. But his principle was confirmed here in the Cumberland Hills, where he found the pure hematite ore he needed. A rich countryside indeed, with such beauty on its face and so much treasure in its heart.
Workington is my town, a town built on iron. It stands alone between the hills and the sea. Maybe that's why we're an independent, self-contained sort of people. Like many industrial towns, it's a mixture of old and new. Older terraced houses and newer spacious estates. Proud of our past and confident in our future, we are generally considered a lively, friendly people. 30,000 of us, living, working and playing together in a community built on our Bessemer heritage. A heritage that has transformed the old ironworks of yesterday into the fully integrated iron and steel works of today. To maintain their full capacity, we have to bring in to our own docks raw material from other parts of the world. Yet the basic foundation of Workington still lies under the foothills of the Lake District, where the pure hematite iron ore, which Bessemer sought a century ago, is still being mined. After it has lain here for many thousands, indeed millions of years, it gets a rare blow of good Cumberland air on its way to town. In addition to our local ore, other hematite ores are brought from Africa, Sweden and Spain.
From mines and docks, there's a steady flow of ore for the blast furnaces. Of course, ore alone does not produce iron. It needs coke, high-grade coke from Cumberland coal, and ovens designed to suit the coal. Over 6,000 tons of coke a week are produced in 2 batteries of 64 coke ovens. And it all has to be taken along to be quenched under sprays of water. The steam cloud formed by the cooling coke is a familiar sight to the townspeople. They know that the coke is going to the blast furnace to be mixed with lime and crushed ore to produce more iron. The 3 ingredients in weighed and measured quantities go up to the sky in skips. Three blast furnaces working continuously can produce 9,000 tons of molten hematite pig iron every week. Every 4 or 5 hours, a furnace is tapped. The molten iron runs out, and the mastery of man over metal begins. On the skill of the blast furnace keeper depends the success of each tapping. For this is not only the story of hard-won metals and the white fury of furnaces. It is also the story of men who have been born and bred to iron and steel. The men who will control and shape this flowing mass until at last it takes its destined form.
Movement control is essential here. Everything must be put in its right place at the right time. From the furnace, the molten iron goes to the Bessemer's shop for hot storage. High up, the crane driver looks down and takes charge of the ladle to raise it to the mixer. The mixer holds 400 tons of molten iron, literally in hot storage. By mixing casts from the blast furnace, it levels out any variations between them. So a uniform quality of iron can be sent on to the converter. The Bessemer converter is a steel shell with its mouth set at an angle. It is lined with silica brick, a chemically acid material, hence the name acid Bessemer. Through these holes, or tuyeres, air is blown under high pressure. The blower, in his cabin opposite, is the kingpin here. He signals when he's ready for a ladle of iron to be brought from the mixer. Indeed, he times every move to keep production flowing smoothly. The shape of the converter allows it to hold the molten metal during filling, so that it is clear of the tuyeres. When the 25 tons of molten iron is emptied into the converter, the blower turns on the air. The blow has begun, and the air blast sweeps from the tuyeres across the surface of the metal. Though he has many gauges and instruments to help him, the blower's experience and cool judgment will guide the furious clash of air and metal. When the air is blowing at full blast, the converter is tilted up. going through the metal now and starts to burn out silicon, manganese, and carbon. Keen eyes are fixed on the flame, its changing color indicating what is happening inside the converter. Strap is used to control the temperature of the molten metal, a vital factor throughout the whole of the blow. Rocking is the blower's version of shake the bottle. It helps to melt and mix the scrap. The gradual change in the color of the flame means that the silicon and manganese are burning out. As these elements burn, the temperature shoots up and the carbon also begins to burn. Soon, the oxygen in the air, combining with the carbon in the metal, forms carbon monoxide. The result is a fierce flame burning at the mouth of the converter, a warning signal to the blower. Now is the critical period when the flame turns white. Every eye is concentrated on the flame, for the moment to end the blow, when the carbon is finally burnt out, must be judged exactly. The fury of the blow is spent. The molten metal inside has become almost pure iron. To make it into steel, a controlled quantity of ferromanganese is added first. Next, an alloy of iron and manganese, called spiegel, is poured in. This increases the carbon content and turns the molten iron into steel of the right analysis. While the molten metal is being poured, a further addition, ferrosilicon, is charged to the steaming ladle. Man still controls the flow of metal. Now he must give it a solid, practical shape, one in which it can be worked in the rolling mills. That solid shape is obtained by teaming the steel into ingot molds. You can see here the result and importance of movement control. As the molds are filled, a second converter is already being blown. Further on, molds from the previous teaming are being stripped. These go to what are known as soaking pits, which already contain ingots stripped earlier.
Soaking means exactly what it says. The ingots are literally soaked with heat for about 2 hours, reaching a temperature of 1200 degrees centigrade before they are ready and malleable enough for the rolling mills. flame of the converter, lighting up the Bessemer shop, is the very spirit of the works, always ready to draw our eyes and our breath. The ingot will become a steel rail, and the quaintly named chariot takes it to the cogging mill for the first stage of its transformation. Every backward and forward roll and turn will slowly shape this ingot into what steelmen call a bloom. Above the mill, in the pulpit, men are still the calm and patient masters of the metal. With quiet concentration and perfect understanding, they roll the steel to exact size and of right strength and internal structure. The ingot is now a bloom to be passed on for further rolling. They call this the roughing mill. The bloom would probably call it much the same. With each pass, the bloom becomes longer and thinner, and soon it begins to take on the shape of a rail. Roughing being completed, now over to the finishing mill. Men still take a hand in turning the rail, for it has to be rolled sometimes on the flat, more often on the edge. Even the rail seems pleased with its progress, wagging its tail as it passes through. In cutting to rough length, allowance is made for contraction during cooling. It can contract as much as a foot. When the rail is a cold 60-footer, it has to be made perfectly straight, so another rolling process smooths out any irregularities. This machine performs the final operations, cutting to exact length and drilling holes for the fish plates. The rail has come a long way, from the ore mines through the blast furnace and the converter, the soaking pits and rolling mills. And how this sight would have delighted Henry Bessemer. For these and every rail produced here are made by his original steel-making process, which he patented a century ago.
At Workington, we like to feel that we have repaid a debt. 100 years ago, Bessemer gave us the chance to make full use of our natural wealth and our inherited skill. On that, we have built a great works, a fine town, and a good way of life. railways in Britain and all parts of the world, you will find rails made from acid Bessemer steel, a tribute to the genius of the man who invented the process. British railways, one of the busiest systems in the world, use 250,000 tons of new rails every year.
As trains become faster and loads increase, these rails will be ready to take them. Henry Bessemer, a century ago, may not have foreseen the great railway systems of the world today, but he lived to see the beginning of the steel age, which, more than any man, he had made possible. Its continued growth is a fitting memorial to his genius.